EES, which is an acronym for Engineering Equation Solver, is a computer tool that is unlike any program that you have ever seen. EES can solve up to 12,000 simultaneous algebraic and differential equations. It can check the unit consistency of these equations and provide unit conversions as needed. It provides tables with capabilities that are similar to but more powerful than a spreadsheet program, and it can easily generate publication quality 2D and 3D plots of various types. The equations entered in EES can be used to develop models across a range of disciplines, and then native optimization algorithms and uncertainty analysis can be applied to these models. For example, the genetic optimization that is shown here. EES provides built-in, high-accuracy thermodynamic and transport data for hundreds of substances, as well as powerful heat transfer and fluid flow libraries. EES models can be coupled with a graphical user input-output interface that can be animated and even distributed to provide standalone executables. These distributables can even be placed on a web server in order to allow widespread access. With these capabilities, EES has become the most widely used tool for mathematical analysis of thermal energy systems. It is currently used at thousands of companies and more than 500 universities worldwide. Let's look at a few of these capabilities in more detail. The basic function provided by EES is the numerical solution of linear and nonlinear algebraic and differential equations. EES is fundamentally an equation solver, which is different from formal programming languages such as MATLAB, C, or Fortran that utilize assignment statements. Equations in EES are relationships between variables. The equations can be entered in any order with no concern for which variables are on the left or the right sides of the equal sign. Internally, EES automatically identifies subsets of equations that require simultaneous solution, and then uses sophisticated built-in iterative techniques to efficiently solve the equation set without any user intervention. Variables in engineering problems typically represent physical quantities such as pressure that have units. EES allows you to assign not only a value to each variable but also its units. EES will then check the unit consistency of each equation, and any unit conversion errors will be flagged. Further, EES facilitates the process of converting between units by including a large number of built-in unit conversion factors. The unit checking and conversion capabilities are incredibly useful features that help to ensure that correct results are obtained. EES provides high-accuracy thermophysical property data for hundreds of substances such as steam, most refrigerants, many hydrocarbons, cryogens, high-pressure air, and many other fluids. Property data functions are implemented such that any property can be obtained in terms of any combination of independent properties. Thermodynamic properties can be visualized using automatically generated property plots, such as the temperature entropy plot for water that is shown here. States that are relevant to the system being considered can be overlaid onto these plots in order to quickly visualize complex processes and cycles. EES provides libraries that facilitate the solution of heat transfer and fluid flow problems. The heat transfer library includes functions for most every correlation or plot that appears in a textbook that might be required to solve a heat transfer problem. Some examples include an extensive library of convection correlations for internal, external, and natural convection flow problems, radiation view factors, heat exchangers' effectiveness NTU solutions, compact heat exchanger correlations, conduction shape factors, boiling and condensation heat transfer relations, fin efficiency solutions, fouling factors, and other related information. EES is particularly useful for design, as the effect of one or more parameters can be parametrically investigated once a model is complete. The program provides the capability to do these calculations using a parametric table. The user identifies the variables that are independent by entering their values in the table cells, which are shown here in black. EES will then run the model using these inputs and calculated the associated values of the dependent variables in the table, here shown in blue. A natural use of EES is the reduction of experimental data. For example, this test facility is used to measure the heat transfer coefficient of an internal flow. The applied heat transfer rate and the inlet, exit, and wall temperatures of the test section are all measured, and then the heat transfer coefficient is computed based on these measured quantities that are shown in red here. Of course, EES can be used to compute the heat transfer coefficient itself. However, a very important aspect of any experimental analysis is the propagation of experimental uncertainty, and EES greatly simplifies this process. In addition to units, all of the variables in EES can also be assigned an uncertainty. The uncertainty of EES variables can be specified when they are measured quantities, and then the uncertainty in the measured quantities can be automatically propagated through the calculations in order to provide uncertainty estimates for calculated variables. Used with the parametric table, data and results calculated from data can be shown in a plot that includes automatically generated error bars. EES provides the capability to develop an easy-to-use graphical user interface with its diagram window. The diagram window provides a screen on which to place a schematic or a graphic. The graphic can be prepared using the drawing tools provided in the diagram window toolbar, or can be copied from any drawing program. Inputs to the calculations can be entered in edit boxes directly in the diagram window instead of using equations in the equations window. Text can be placed at any location on the diagram window in order to display calculated information from the EES program. Drop-down lists, radio button groups, checkboxes, and slider controls provide alternative input methods. Diagram and child diagram windows provide a visually appealing interface to complicated analyses. EES programs that have a graphical user interface can be packaged into a distributable program. The distributable program can then be provided to users as a standalone executable program that can be freely distributed. These programs can also be used as the front end of a web server in order to provide internet access. This video has only demonstrated a few of the capabilities in the EES program. There are many more, such as macros that can control EES programs and allow it to interface with other programs such as LabVIEW, Excel, and MATLAB. EES provides unusually powerful tools for any engineer that is involved in analysis and design. Engineers are using EES in industry and in academia, and its popularity is growing. Perhaps you also should be using EES. See our website for more information.